Welcome back, everyone. We are working on section 9.1, coordinate geometry today. This section should kind of be a review of some of the things we talked about previously in this course. It's all about classifying triangles and quadrilaterals based off the endpoints you're given and proving it. So we could obviously take these things and plug them into the to a graph, like graph them onto a coordinate plane and see what happens. And that would give you a good idea of what's going on, but it's not the... Sorry about that. So again, we can't graph these. We have to actually prove it so that we have justification in mathematical numbers. So the first one, we have a triangle. So I know I'm going to graph I'm going to classify this as either acute, obtuse, or right. And I'm going to classify it as scalene, isosceles, or equilateral based off of sides. So the first thing I'm going to do is I'm going to find the distance for all three sides. So the distance from J to K, which means we're going to need to use our distance formula. If you don't remember what that is, we can write that up here real quick. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you've forgotten that, there it is. So we are going to do that right here with this. So I'm going to start with J to K. So x2 is negative 9 minus negative 7 squared plus 1 minus negative 7 squared. So I can see that when I do this, I'm going to get negative 9 plus 7, because the minus and negative is going to become a plus. So this is going to be negative 2 squared. 1 plus 7 is going to be 8 squared. So I get 4 plus 64, which is equal to the square root of 68. Again, notice right here, this negative 2 squared became a positive. That's really important. You should never end up with negative numbers at this last step when you're adding things together. They should always be two positive values. So going on, we're going to keep doing this. We've gone, and notice I didn't actually finish solving this. You could, and you'd get 8 point something, but there's no reason. That's good enough. And you're going to see why. When we compare that to everything else, we know that square root of 68 is going to be bigger than square root of 61, for example. So I don't really need to keep going. That is good enough for me to solve that problem. So I did J to K. Let's go K to L next. So K to L, we're going to do the same thing. x2 minus x1. So I've got negative 1 minus negative 9 squared plus negative 1 minus 1 for y squared. Right here, negative 1 plus 9 is going to give me 8 squared. Here I got negative 1 and negative 1 again, so I'm going to get negative 2 squared. Those numbers look familiar, don't they? So we get 64 plus 4, and again, I get square root of 68. So at this point, I know two of the sides are at least equal. And the last one is to loop back around. I went J to K, K to L, and now I go L back to the beginning of J. So x2 minus x1 is going to be negative 1 minus negative 7 squared. Negative 1 minus negative 7 again. It looks like we're going to get the same answer twice here. So negative 1 minus negative 7 is going to be negative 1 plus 7, so that gives me 6 squared. Same thing there is another negative 1 minus 7, so another 6 squared. 36 and 36. Looks like I'm going to have the square root of 72. So the first thing I notice is that two of my sides are equal. Remember that in triangles that had two equal sides, we referred to those as isosceles triangles. But we also need to figure out if this triangle is an acute, an obtuse, or a right angle. And we do that by using the Pythagorean inequalities. C squared is what to a squared plus b squared? Remember, if c squared is equal, it's a right triangle. But if c squared is less than a squared plus b squared, we know it's an acute triangle. And if c squared is bigger than a squared plus b squared, it's an obtuse triangle. I just have to make sure that I plug in the biggest one for c. So in this case, the biggest one is 72. I leave my blank spot for the question mark because I don't know what goes here. And then I have a squared plus b squared. Notice that I just dropped the square roots because square root of 72 squared is 72. That is c squared. The square root of 68 squared is 68. Square root of the other 68 squared is 68. Look, we're done. And now you just got to fill this in. Is 72 less than, equal to, or greater than 68 plus 68? And I think that one's kind of obvious, but let's finish setting it up just so we can see it. We're going to get 136 here, so I know 72 is definitely less than 136. So since it's less, it's an acute triangle. So this is an isosceles acute triangle. Example 2, we step up to a quadrilateral. So now I have a 4 points that I have to find. So I'm going to do distance formula 4 times here. So S to T, T to U to V, and V back to S. So S to T to U to V, V back to S, and we are going to set up our distance formulas there. So again, wrong column. I got square root of -9 minus 1 squared plus 14 minus 10 squared. Working this out, I got -9 minus 1, which is going to give me -10, and -10 squared is 100. 14 minus 10 is 4, and 4 squared is 16, so I get 116 square rooted. For TU, I've got x2 minus x1 is -3 minus 1 squared plus 0 minus 10 squared. -3 minus 1 is going to give me 4. -4 and -4 squared is positive 16. 0 minus 10 is -10. -10 squared is positive 100. Look at those numbers. They're the same. What? All right, going on to UV. -13 minus -3 for x2 minus x1 minus -3 squared. 4 minus 0 squared. So this is going to be plus 3. So -13 plus 3 is 10. 10 squared is 100. And here I've got 4 minus 0, which is going to be 4. 4 squared is 16. Another square root of 116. Interesting. One last one. V back to S. So square root of -13 minus -9 squared. And 4 minus 14 squared. -13 plus 9, because there's a minus and negative, is going to give us -4. And -4 squared is 16. 4 minus 14 is -10. -10 squared is 100. And for the 4th time in a row, I almost said 3rd time. For the 4th time in a row, we got 116. So what this tells me is all 4 sides are the same, which gives me 2 ideas. It is either a square or a rhombus, right? We know that a rhombus has all 4 equal sides, and it passes that property down to a square. So a square also has 4 equal sides. So we need to decide, is this a square or a rhombus? The easiest way to do that is to do 2 more distance formulas. The diagonals. If I find the distance of the diagonals, then if it's equal, it's a square, because squares have equal diagonals. If it's not equal, it's a rhombus, because it's a crooked shape. It's like sideways, so the diagonals aren't the same. So let's do that. The diagonal is going to be S and U and T and V, those 2 matching colors. So I'm going to find S to U first. So S to U is going to be -3 minus -9 squared, and 0 minus 14 squared. -3 minus -9 is going to be plus 9, so it's 6 squared, so that's 36. And 14 squared is going to be plus 196. That's going to be some big numbers. 202, 232. All right, let's check the other diagonal. T to V, T to V. So T to V, we're going to take the square root, -13 minus 1. -13 minus 1 squared. 4 minus 10 squared. Again, this is going to give me 14 squared. That's going to give me -6 squared, and those are the exact same numbers. So ultimately, we're going to get 232 again when you work that out. That is going to come out to the same thing. So since the diagonals are the same, I know this is a square because the diagonals are equal. All right, in example 3, we've got another problem asking us to classify by our angles again. I'm going to speed through these distance formulas just to kind of save you some time, because I think you can see how that's going to happen now. So I've gone through that there and done my 3 distance formulas, and it looks like xy gave me square root of 8, yz gave me square root of 5, and zx gave me square root of 9. All three of those are different. So what this tells me is this triangle is definitely a scalene triangle. Remember, scalene means all three sides are different. Again, I've also got to classify it by its angles too. So I'm gonna set up my little Pythagorean inequality. So c squared goes on the left. C has to be the biggest one. It's gonna be 9. So square root of 9 squared is 9, is blank, to a squared, which is 5, square root of 5 squared, which is 5, plus b squared, square root of 8 squared is 8. So when I work this out, I get 9 is blank to 13. And I know that 9 is definitely less than 13. So just like example 1, this is a scalene acute triangle because it's a less than sign there. All right, we got 3 more examples of this. So again, I'm going to go through those distance formulas very quickly so we don't have to look at them again. Because if you're struggling with distance formula, there's a whole nother video for you to watch on that. So hold on 2 seconds and you will see all of it done. Ooh, 2 seconds, boom, done. Told you it'd be 2 seconds. All right, so there's A, B, B, C, C, D, D, A done. I kind of shorthanded it to do it kind of quick. You can see all 4 sides came up different. This leads me to believe one of 2 things, right? This could be nothing special. It could just be a boring, basic quadrilateral, super basic. But it also could be a trapezoid. Remember, to be a trapezoid, it doesn't matter what your side lengths are. All that matters is that 2 sides are parallel to each other. So when this situation happens where nothing matches, you also have to test the slope of each side. So we're going to find the slope from A to B, B to C, C to D, and D to A, okay? And what will happen is if any of the slopes are equal to each other, then there are parallel lines, which means it could be a trapezoid, right? It can't be a parallelogram because they have to have equal sides. But if there are parallel sides, it is a trapezoid because trapezoids just need one set of parallel sides. The slope formula, if you don't remember, is very similar to what we were just using. y2 minus y1 over x2 minus x1. So I'm going to go down and find the slope of each one again. So A to B. A to B, the slope here, -1 minus -3. -1 minus -3 over -4. I did that upside down. What am I doing? Y'all. Okay, try that again. y2 minus y1. I need to do y's. I did my x's on top. I was just doing it to see if you'd catch it, that's all. -4 minus -2 over -1 minus -3. So that's going to be -4 plus 2, which is -2. -1 plus 3, which is +2. So -1 is the slope of A to B. B to C, we're going to go 0 minus -4 over, and then x2 minus x1, 4 minus -1. So this is going to give me 4, and this is going to give me 5, so I got 4/5. Take a note here that in the previous examples, you may have noticed that really the order of x2 and x1 didn't matter, and y2 and y1. In slope, it does. You have to be very careful in slope that you're putting it in the correct order. The other ones, you could make those mistakes and it wouldn't cause too much of a problem. But in these problems, if you don't do it correctly, you are going to run into an issue. So 6 minus 0 and 7 minus 4, I get 6 over 3, which simplifies to 2. Okay, one last one. D back to A. So y2 minus y1, -2 minus 6 over x2 minus x1, -3 minus 7. So -2 minus 6 is -8. -3 minus 7 is -10. That simplifies, those negatives cancel out, and I get 4 over 5. Ooh, look at that. These two slopes are equal, which means there are parallel sides. So this shape is going to be a trapezoid. If none of those were equal, again, we would have just put quadrilateral, and that's it. So there is that example 4. All right, on to example 5. Let me do those distance formulas for you. Hold on 2 seconds again. All right, so again, there are my distance formulas done. A to B is square root of 26, and B, C, and CA are both square root of 13. So this tells me I have 2 equal sides. In terms of a triangle, that means one thing. It is isosceles. Now, I noticed in these examples, the one that we didn't see is if all 3 were equal. If you don't remember what that word was, it was equilateral. That would be an equilateral triangle. So now we've talked about all 3 of them. Okay, again, we're going to classify based off of the angles. So I've got C squared is something to A squared plus B squared. We need to fill that in. C, in this case, looks like it needs to be the 26 because that's the biggest. So 26 squared, square root of 26 squared is 26. A squared and B squared are going to be these two, and when I square them, it gets rid of the square root, so I've got 13 and 13. Some of you may see what's about to happen here. When I bring this down, 13 plus 13 is 26, so these two things are equal to each other. Remember, we said if it's less than, it's acute. If it's greater than, it's obtuse, but if they're equal, it is a right triangle. So that's an isosceles right triangle in example 5. And that brings us down to this last example in this very long video, example 6. Let's get those distance formulas put on there. All right, so there are my distance formulas, wx being square root of 5, xy and yz being both square root of 13, and zw also being a square root of 5 like the first one. There is something very important about this pattern that I want you to take a note of. Notice that in this example, how it went 1, 2, 2, 1. Because what that's showing, and if you were to draw this picture, you could see it a little bit clearer. There's my quadrilateral, w, x, y, z. W to x is square root of 5. X to y is square root of 13. Y to z is square root of 13. And z to w is square root of 5. Notice that it's not opposite sides that are equal here, but consecutive sides. I could draw this shape a little bit better, and what we'd actually be seeing... that was not better. Hold on. I'm going to turn it. Because I can draw kites that way, because that's what it is. When these two are equal, and then these two are equal, we refer to that as a kite. That's the only name for it. It has to be a kite, because here and here are equal, and here are equal. So this would be a kite, since the consecutive sides are congruent to each other. I hope that helped you all out. If you have any more questions on this, please let us know, and we will see you all next time in class. Bye, everybody.